Hi everyone, this is NA RISU. The radio is recorded for the course KIB1016. Today we will analyze a common emitter amplifier circuit. We will perform DC analysis and AC analysis, and calculate the small voltage parameters, and draw the small signal equivalent circuit, then calculate the small voltage gain for the amplifier. The first part is the DC analysis. We need to calculate the DC operating point VCEQ and ICQ. The circuit diagram used for DC analysis can be simplified to the left diagram. We need to find RTH and VTH before we proceed with our following steps. RTH can be seen as a combination of R1 and R2, where R1 and R2 are in series. With the voltage divider law, we can calculate VTH. Substitute values for R1, R2, and VCC. We get RTH equals to 20 kΩ and VTH is 3 volts. Then we apply KVL to loop 1. We get equation 1 where IE equals to the sum of 1 plus beta multiplied with IB. Substitute the expression for IE to equation 1 and rearrange it. We have the expression for IB. Substitute the values for VTH, VBE, RS, RTH, RE, and beta to the expression of IB. Calculated IB equals to 4 mA. IC equals to beta IB equals to 2.212 mA. Then we apply KVL to loop 2. We get the second KVL equation, where IE equals to the sum of 1 plus beta multiplied with IB equals to 2.216 mA. Substitute values to equation 2. We calculate VCE equals to 7.918 volts. Now we have the DC operating point at 7.918 volts, 2.212 mA. Now we move to the AC analysis. The transconductance Gm and the small signal input resistance looking into the base of the transistor can be calculated with formulas below. Where from DC analysis, we already get the value of ICQ and the thermal voltage assumed to be 26 mV. Substitute the values. We have Gm equals to 85.8 mA over voltage, and RBE is 11.75 ohm. Then we construct the small signal model and calculate the small signal voltage gain AV. The small signal model is shown on the left diagram. According to the formula, the voltage output Vout equals to minus Gm multiplied with VBE and the combination of RC and RL, where RC and RL are in series. The value of VBE can be calculated by applying the voltage division law. Substitute the expression for VBE to Vout and transfer Vs to the left-hand side. We get the expression for the small signal voltage gain AV. Calculate the value for RL and RC in series, which is 1.8 kΩ, and substitute Gm, RTH, the series of RL and RC, RS into the expression of voltage gain. We calculated that the small signal voltage gain is minus 145.85. The negative sign indicates that the output signal is inverted relative to the input signal, meaning that there's a 180-degree phase shift. The value means that the output voltage is 145.85 times the input voltage. This video demonstrated the analysis of a CE amplifier circuit. With DC analysis, we have found the operating point for the circuit. With AC analysis, we have found Gm and RBE and the small signal voltage gain for the circuit. I hope this video really helped, and thank you for watching it.